you can just note down the steps how you can access BioPython using PyCharm, and then after the class ends, you can just download it and try and running it again. Okay, because even if you don't have BioPython, you can still run certain programs on PyCharm which don't require the use of BioPython. I will be telling you like what particular specific programs will require BioPython and which one won't require BioPython. So you can just note down the steps how to actually use PyCharm and BioPython together. Okay. So once you have created a new project, just create a new file, whatever file you want. Let's say I write it test1.py. So everyone created their new file.
Yes, sir.
Okay, now what you need to do is just go here on file option and go to settings. Okay, it'll take some time to open the folder. Okay, now once the settings are open, just go and see on the left hand side, you will be seeing like a short version here seeing project BioPython. So the name of the project, whatever project you have created, that will be the name which will be shown here. Just click there, and then there will be two options: project interpreter and project structure. Just go to project interpreter, and here what you can do is you will be seeing a plus sign over here. Right now, here you can see I have already like installed BioPython. So, but I guess in your cases, BioPython won't be showing here. So what you can do is just go and click the plus sign over here, and then there will be a search bar over here. Just type BioPython, right? And you will get a file called as BioPython here. Just click on it, and then just click here install package. It will take some time, like it might take 5 to 10 minutes to install the package depending upon the network, how speed your network is. So just search BioPython here, click on the first one, and just click on install package. It will take some time. Okay, so I will be giving you 5 minutes. If you want, you can just do it, and after 5 minutes I'll just like have a quick check whether it's installed or not. Okay, so you guys can do it.
Excuse me, sir.
Yes, yes.
I installed BioPython. How
Mhm.
am I exactly supposed to extract the file?
Okay, so what you need to do is for example, let's say I have my Python installed in my C drive here as a name Python. Okay,
Okay.
what you need to do is just take your extracted folder BioPython and paste it
Okay.
here, and just extract the file here itself inside Python folder. Okay, just extract it here.
Okay.
Yeah, and once it is extracted, then you just need to go to PyCharm and do the rest of the things as I already told you. Yeah. Does anyone have any issue with how to access your BioPython in PyCharm? I can repeat it again if you want.
Yeah, sir, it will be good if you repeat it.
Okay, so the very first thing is you have to create a new project, and inside that project, create a new file .py. Now, once your file is created, just go here to the file option, and in the file option, you'll find settings. So just click on the settings. Here on the left hand side, you will see your project name, whatever project you have created with whatever name it is. You will see a link here. Just click on it, and then there will be two options inside that one. One is project interpreter and project structure. Just click on project interpreter, because now what happens is by default PyCharm will be using Python, but there will be certain programs which require you to install BioPython also. So what you need to do is you need to give access to your project the BioPython package as well. So here you can see I have a BioPython already installed here, but I guess if you're doing it for the first time, BioPython won't be there. So here is a plus sign. Just click on the plus sign, and there will be a search option on the very top. So just in the search bar, just type BioPython, and once if you have extracted it, you will see BioPython being the name of the BioPython being shown here. Just click on it, and uh, on the bottom left side, you will see a option of install package. So just click on the install package. Wait for some time. It might take 5 to 10 minutes, because it will also depend on the type of connectivity you are having right now. So if it's a good network, it will install the package quickly, but it takes around 5 to 10 minutes. Okay, so just click on the install package, and then you're done. Then close everything, and you can start off with your project. Okay, so I'll give 5 minutes to everyone. Just try and install it, and I'll quickly revert back after 5 minutes. Okay. Is it clear now, everyone?
Yes, sir.
Yes, sir.
Oh, okay. So I'll quickly come back after 5 minutes. Okay. Now, initially, what will be happening is we will first see the basics of BioPython is and why there was a need to introduce BioPython. And then we will be looking at the basic examples of like figuring out how things work out in BioPython. Now, the thing is, initially, we will be looking at some of the examples whereby we will be importing BioPython. But some of you who don't have BioPython installed as of now, you can also run the same program because the data that we will be taking, like the DNA sequences, those will be basically working as a string. Like, so it doesn't matter whether you import BioPython or Python, it doesn't matter at all. So because our DNA sequence works as string initially, so whatever parameters or whatever attributes which are true for a basic string, that will also work here in the same way. And the only thing differing here will be when we will be specifically importing the data from the servers like NCBI or GenBank. At that time, we will be strictly using BioPython. Right? So I'll be telling you
Sir,
when. Huh?
sir, I installed the BioPython package just as you said.
Mhm.
After installing, it's showing installing, and then on the right side of the install package, it is highlighting the managed repositories. So, what should I do now?
I didn't got you. Can you share your screen and
Sir,
show me
so
like what
my
exactly?
package has been installed successfully, and there's
Mhm.
nothing else. Should I just exit that part of the
Yeah, yeah,
screen?
yeah, yeah. Yeah, yeah, yeah. If it's installed, just come back to this particular workspace area.
So I close it, right? The available
Yeah, yeah,
packages screen.
Sir,
yeah, yeah, yeah.
my package is also installed. It's showing
It's
now.
installed, right?
Yeah,
So like you all went from this setting menu and then like added BioPython from here. And
just
once
as
you
you said,
chose
sir.
BioPython,
Yeah.
yeah, yeah.
We proceeded the same way.
Okay, okay. And after installing package, it said the package is installed, right?
Yeah.
Yeah. So
Yes.
just close it and come back to this workspace here.
Okay. Thank you, sir.
Okay. So now first we'll be understanding why there was a need to introduce basic BioPython. So what happened was when bioinformaticians were faced with the problem of data procurement, then there was a idea to make a separate package using Python because at that time Python was a very easy language to understand and it was like booming really fast in any industries. And bioinformatics industry were also like on the verge of the extinction because people were like giving private companies their data to do all the sequence analysis and everything. So what happened was the data procurement was a very big issue that was faced with all the people working in industry. So people thought that why not introduce a different package that will be storing all of the basic what we can say the basic codes. For example, let's say if BioPython wasn't there, then to calculate any GC content or to calculate the AT content of your DNA sequence, you have to write a proper set of codes, and that could be done using anything like you will be defining a function in a general way and then calculating what percentage of A is there, how much percentage of T is there, the total length of the DNA, and then you will be running all those things. So what people try to do was to shorten this particular process that was taking enough time so that people don't have to write all this code. So what did was they wrote the basic code as it is and labeled it as, let's say, GC. Okay, and then they stored this one as a package itself, so that whenever any bioinformatician is working to find a GC content in their DNA sequence, they will just have to import the DNA sequence and just have to import the GC package. That's it, and then it will automatically give the particular person the GC content. He or she doesn't have to actually write the whole set of codes to calculate the GC content or the AT content or whatever it is. Right? So that was one of the major thing which people were facing. So, and apart from that, BioPython also provides you different kind of processes that you can do, like BLAST or cluster multiple sequence alignments to download your data in the form of FASTA format or GenBank format from PubMed or Medline, from SwissProt, different kind of databases. You can download those data. You can do BLAST sequencing. You can do multiple sequence alignments for those things. All these are there are different packages inside BioPython that allows you to do all these stuff also. The only requirement is you have to have a good network connectivity in order for you to download all those things. And also what BioPython allows you is that when you download a particular set of files, you can create a whole set of dictionary for a particular organism. Let's say I give you Pseudomonas, and or let's say I give you Plasmodium, and I give you 5 strains of Plasmodium, and I say that, okay, create a dictionary which stores all the data of the Plasmodium falciparum or Plasmodium whatever species is there, okay, and create a dictionary for that. So what BioPython allows you to do is that you can create separate dictionaries for each of the individual species and store whatever data you want for them. And then you can just call that particular dictionary and it will give you all the data that you have already stored for that particular species. So that you have created a dictionary which is for a repeatable use. You don't have to go back again and again to the data server and download all the required data and then access all those data, whatever it is. So you don't have to do those n number of things. You have already created a dictionary, just call it and everything will be available in front of you. And you can also update whatever new data are coming out. You can update the dictionary as well. Okay? So it gives you a very like a smooth sailing around the work or data procurement. The third thing is that you can like deal with the bioinformatic problems of like whatever it is, like NCBI and XPSI, SwissProt, all these sites. You can directly download the structures or sequences from those. I'm sorry, not the structures, the sequences. You can download it from there. And also it allows you to it basically acts as an interface for different kind of bioinformatic programs like NCBI or ClusterW or multiple sequence alignment or MBOSS, all these things. So it basically acts as an interface between these two things as well. Right. Apart from this, what happens is it allows you to calculate any kind of problem in bioinformatics using a particular set of algorithms. For example, in bioinformatics, I don't know how many of you have studied bioinformatics in your coursework right now. I guess Suchi Nagar teaches you bioinformatics, right?
No, sir. Ipsa
Prakash
ma'am is teaching
Nimade.
us. Nimade sir and Ipsa ma'am.
हाँ.
So
This semester
what does Suchi ma'am then teaches you?
Chemistry.
chemistry.
She
I think
used to teach
And
us.
molecular modeling.
Okay, so because during my time she was the person who taught us, and her bioinfo is really good as compared to Prakash sir. I think she has a better bioinfo grip. As far as I am concerned, I don't know how Prakash sir is teaching right now, but that was the case previously. So what we can do, she will, if like those teachers teach you, they will also, I think it is, whether it is in syllabus or not, I don't know whether your syllabus have been updated or not. But during our time, we were also studying different kind of algorithms that are actually there in bioinformatics, which allow you to, create a relation between two sequences. And there are different kind of algorithms like k nearest neighbors or naive Bayes or support vector machines. So basically this support vector machine is not required as of now for you guys, because this is mainly involved with machine learning programming thing when you will study, or when you will do bioinformatics at a very deep level, like bioinformatics combined with machine learning. At that time you will be studying about support vector machines. But as of now, you can study like basic algorithms which are there. For example, when you do multiple sequence alignment, there is certain kind of algorithm that is working behind the scene that gives you like a sequence alignment of any two sequences or more than two sequences, right? So you can also those algorithms, you don't have to write it. So if you don't have a BioPython package, what you guys need to do is that you first have to define a whole of the algorithm together to Python, and then you can give a particular set of input, and then you can call that algorithm. Otherwise, and that becomes a really like a tedious job, because you have to first define like 100 or 200 lines of code you have to write for a particular algorithm, and then you will be importing all the data. So what BioPython does is it already has those algorithms stored with it. You just have to call those packages and just give the input data, and everything will be in front of you. You don't have to write all those 100 lines of codes, whatever it is. So that is one way of easing things work out for you. Also, you can do a parallelable task. So what parallelizable task basically means is when you run a particular simulation in a computer, whatever your central server is, that central server is still connected in the form of nodes or branches to different servers, right? So there will be a master server, and that master server will be connected to, let's say, 5 servers, and then that 5 servers will be connected to again another 5 servers, and so on. So there's a branching pattern there. And what this branching pattern basically does is it allows you to speed up the process. So let's say if there is only one server and 100 students are carrying out the bioinformatic practical or running simulations, transactions, then what happens is there is a very large amount of influx of data to the central server, and the server can crash at that time. So to protect it, what people do is that they create multiple nodes so that you can run several hundreds of programs parallelly, and parallel connection will allow you to run the programs very really smoothly without any kind of lag or server facing any issue. So in the same way, in BioPython also you can do the same thing. You can create or split up your programs into parallelizable spaces. So let's say you want to simulate 5 or 6 sets of DNA strands you have, and you want to find similarity or whatever you want to do. You can create splitwise programs for each one of those and assign separate nodes to your central server, and then all those nodes will be running your particular program without crashing the server. So that is one way to optimize your program. Basically, it's a type of an optimization that you can do. Also, BioPython is a type of a GUI, so that is a graphical user interface whereby it allows the user to manipulate whatever you want, like any particular kind of sequence data, protein or mRNA data, whatever you want, you can actually manipulate it using your BioPython. So that is one way of giving user all the hands-on approach to give the user a particular kind of freedom to play around with the sequences and then try to twitch up the codes and try to accommodate everything according to the user's need, or whatever the data wants or whatever the program requires it to be. So that is one thing. Another part is just as BioPython, there are also other programming languages that are specifically designed for bioinformatics, like BioJava, BioPerl. BioPerl, I think it's still in your coursework. I guess in 6th semester you might be studying BioPerl as well, right? But the only thing is, BioPerl doesn't have a future as of now, as compared to like BioPython or Python, right? So that is one thing that we have approached Palsar to eliminate it from your syllabus. Like, don't make students study BioPerl, instead make them study BioPython. That is one thing that will be, I don't know whether they will agree to this or not. It depends upon Palsar. But if this happens, then I guess it will be good for you guys, because BioPerl, because once you graduate from the college and you go to an industry level, you will see not much of the industries are using BioPerl. Like, some of them don't even know what BioPerl is actually. So it's better if you can stick to BioPython and Python instead. Okay. So this was like a basic of why we should be studying BioPython and what all advantages it offers you. We'll also quickly be looking at some of the basic examples. So let's say you have a particular DNA sequence with you, and let's say I write it as define it as my sequence, and I give it whatever I want, like let's say ATGC, whatever it is, right? So there are certain basic requirements that are required for the user to understand. The very first thing is to do the upper or lower case or case changes of your DNA sequence. So what you can do is you can just write print, and let's say I want this particular DNA sequence to all go into small letters. So what I can do is, first I will call my sequence, that is my sequence, and there is an inbuilt function of Python which allows you to make all the letters small, that is dot lower followed by a parenthesis. So what this will do is that it will lower all the capital letters that you have in your sequences into a lowercase letters, and you can just do your print run, and you see the output is every DNA nucleotide bases which are there in your sequences, all of them have been transformed to a small letter. Yeah. In the same way, you can do for small letters as well. Let's say you have a DNA sequence which consists of all the small letters, like whatever it is, and you want it in a capital letter. So just change lower to upper, dot upper, and it will change every of your sequence to a capital letter here. Okay, so for these kind of things, you don't require BioPython, because what is happening here is this is a string, right? So it is not like you're importing any sequence from a server. So until unless your like parsing of the file is not happening, you won't be requiring much of BioPython. The BioPython only plays out when you have to actually import the files or parse the files in FASTA format or whatever format it is, right? Because what is happening here is now this particular DNA sequence is basically a string. So even if you don't import BioPython, normally Python can carry out whatever functions it has, right? Whatever attributes that are true with a basic Python string, that will only be carried out here, because you're not importing anything, you're not defining anything other than whatever you have said here, right? So you can just use dot upper and dot lower to convert any lowercase to upper or uppercase to lower in that way. So this is one very basic thing that you can do. Another thing which is actually required for you to understand is to how to access individual index of a particular element and write corresponding attribute to that index, whatever element is there corresponding to a particular index. So what you can do is, in a similar way, let's say I have this sequence only, and let's say I do everything capital letter. And now what I can do is I want my program to give me an output whereby for each of the element I have an index number corresponding to the letter. That means what output I want is, for example, here A. What is the index of A? Can anyone tell me?
0.
Yeah. So what I want in my output is that my output will print an index number 0, which is equal to A. So I want 0 equals to A as my output. That means every indexing will be listed out, and corresponding to that index, whatever element is present in your sequence, that will also be printed out. So what I can do is I'll run a for loop. Let's say run for. Now what we can change here is that I want two things in my output. First, I want my index, and second thing that I want is the element. So what I can do is I will just write, let's say, for index and letter. These are the two things that I want. So I'll write for index letter in, just as we were doing for when we were studying strings. What we were doing is we were writing like this for x in, when we were defining a string, we were writing for x in A, and then we were running everything. So in the same way, what we are doing is we are replacing x with index and letters, because I want the output to be index and letters. And from where I want my index and letters to be, it should be from my sequence, right? But what we can do here is that instead of writing just my sequence, it will give you an error. I will show you what error it will give you. So what we can do is we can change it. What we can write is we will write, okay, first let me just show you what error you will get and then how you can rectify it. So what we can write is for index letter in my sequence, and then let's say I want to print. Now what I want to print is I want to first print my index. So how you can access your index is by writing modulus I. So what modulus I will give you is that it will give you the individual indexing of the elements that are present in your string. Okay, and I want my index, and then I want an equal to sign followed by the corresponding element. So what I will do is I will write modulus I equal to modulus S. Now what modulus S basically does is, modulus I basically indicates your index, whereas modulus S will indicate the corresponding element. S basically stands for string. So because it's a string, so basically it stands for string, and it will be giving you the corresponding element present in that string, which is for this particular index. So let's say first it writes 0. So for 0, it will write A. It will go to this string. It will say, okay, what is the 0th element here? It is A. So corresponding to 0, it will write A. Now, what is happening here is that because this is, you are accessing something, right? So what will happen here is that for Python to understand that there is a particular, you have to give a particular set of values also, right? Because once you write just this much, Python don't understand, because it is inside your inverted commas, right? So whatever is inside your inverted commas, it will be printed as it is. So if the Python prints it as it is, I don't get my required output. So I also have to make Python understand what this percent modulus I and modulus S basically stands for. So what I will do is I will again write modulus, and this time I will tell Python that my first thing, that is modulus I, will basically correspond to index, and modulus S will correspond to letter. That means I'm calling this function from here. That is my index and letter. So more first thing will be the index, and second thing will be the corresponding letter that I want, right? I will do this, and just I will run my program to see whether output is occurring or not. So now see, there is an error. What is the error? It says invalid syntax. Now the invalid syntax arrow is showing for modulus, but keep this in mind, whenever you are accessing a particular element in this way, after giving the definition here, you don't have to follow it with a comma.